Hello, and thank you for tuning in today. My name is Dustin Harrell. I am the project leader for the Rice Fertility and Agronomy project here at the Rice Research Station. And today we're going to do something new. We're going to do a virtual rice school where we're going to talk about some of our research findings that we saw in the 2020 growing season and what that may mean for the 2021 growing season. I'll give you a few hints about some things to keep an eye on when we start growing our rice crop in 2021. Just a little bit about our rice program, our research program that is. The overall objective of the Rice Fertility and Agronomy project here at the Rice Research Station is to enhance rice production in Louisiana by evaluating and improving nutrient and cultural management practices. To that end, we had research at 5 different locations in the state of Louisiana last year, which includes Tensas Parish, Richland Parish, St. Landry Parish, Acadia Parish, and Calcasieu Parish. Overall, we had over 115 small plot replicated trials, which means that we managed over 4,812 plots throughout the season, and to get through the season to come up with some of the results that we're going to talk to you about today. I would like to thank the Louisiana Rice Research Board. Without their funding, we would be unable to provide you some of the research findings that we're going to share with you today. So without further ado, let's talk about what we saw in 2020. Well, in 2020, just to talk about some of the things that we do in a rice fertility and agronomy project here, and one of the main things that we do is we work hand in hand with the breeding program. So in other words, if the breeding program comes up with a new variety and wants to release that variety, we also want to release an agronomic package to go with that variety upon its release. And that agronomic package would include optimum nitrogen rates from our variety by nitrogen trials. It would also include optimal plant population recommendations, or basically what seeding rate should we plant these new varieties as they come out. So it's very important that we come up with this information each year for any new varieties that are going to be out there. Now 2021, we're going to have a lot of different and new varieties that are going to change the landscape of what we have out there. Some of the new varieties that we're going to be looking at next year is going to include the new Previsia line, PVL03. Unfortunately, PVL03, we didn't have any seed available for our research trials, but I can tell you that some of the biggest advance with PVL03 over PVL02 is the inclusion of the PETA gene. This PETA gene is going to give this new Previsia line blast resistance. And this is tremendously important because if you've grown PVL01 or PVL02, you know that it is very susceptible to blast, and because of that susceptibility, we typically recommend that you apply a 2 fungicide application for those two particular varieties to maintain or reduce the blast susceptibility of those varieties. Well, with the advent of PVL02 over PVL01, we saw that we finally increased our yield. And now with the advancement of PVL03 over PVL02, not only are we going to increase yield a little bit, but we're also going to improve that blast resistance. So no longer do we have to use that 2 fungicide application for PVL03. Moving on to the next new release that you're going to see in 2021. This is going to be a release from the Nutrien. This is a variety that was developed not by a public university, but by Nutrien with their breeding program. The variety is called DG for Dynagrow 263L, L for long grain. So this is Dynagrow's new long grain variety release. This variety is actually pretty exciting because it is a very high yielding variety. In fact, if we looked at Dr. Famoso's variety trials across different locations last year, it yielded very similarly to CLXL 745, meaning now we have a variety, at least in our limited testing, that is yielding consistently like a low yielding or lower yielding hybrid. So has a definite yield advantage over our other varieties, but Not quite that of a hybrid, but we're very excited about this variety. Um, doesn't seem, we'll talk about some of the nitrogen needs of this variety and seeding rate. Um, but the only negative that I can think of with this particular variety is it is a little bit lower on the milling end as some of our other conventional long grains. The other new variety that we're going to see next year is CLL17. This is a new clear-field long grain variety that was developed here at the LSU AgCenter with Dr. Adam Famoso. And we'll talk about its agronomic package and what we found in research as well. But this is a very exciting variety, and you'll probably see quite a bit of it in the 2021 rice growing season. So with this first chart, this is a response or a V by N trial for the Dyna-Gro 263L to nitrogen rate on a Crowley silt loam soil here at the Rice Research Station in 2021. On the x-axis, you see our nitrogen rate ranges from 0 to 210 pounds of nitrogen per acre. On the left of the hash mark, these are single pre-flood nitrogen applications. And on the right of the hash marks are our split nitrogen applications. Here you can see the 75 pounds of nitrogen applied pre-flood with the second 45 pounds of nitrogen occurring at mid-season. On our y-axis we have our yield in pounds per acre. And here you can see as we increase our nitrogen, for our pre-flood nitrogen, we see an increase in yield until it begins to steady off around 90 pounds of nitrogen per acre for our single pre-flood. For our split rate nitrogen applications, you can see that it increases above 90 and begins to stabilize at about 130 pounds of nitrogen per acre. When we look at the results of this trial, we see that 90 pounds of nitrogen per acre was the optimum nitrogen rate here on the Crowley silt loam soil. And if we were splitting nitrogen rate applications, the 130 pounds of nitrogen was optimum. So this is staying right at our typical semi-dwarf long grain varieties that we have seen over the past few years as far as nitrogen. When we switch from a silt loam soil to a clay soil, this is a clay soil at our St. Joseph Research Station location. Here you can see that we did increase nitrogen as we increased yield, as we increased our yield as we increased our nitrogen rate again. This time we see the optimum rate of nitrogen was about 120 pounds per acre as a single pre-flood nitrogen application and 150 pounds of nitrogen in our split nitrogen rate applications. You can see the asterisks with the different on the different columns. This is indicating that we did see some lodging with this particular variety, but you have to remember that this was from some of our tropical storms. We did have to harvest this after a tropical storm, so I wouldn't be too concerned with this particular variety with lodging, at least in our limiting data that we've seen so far. The optimum nitrogen range that we're going to recommend for this particular variety is going to be 120 to 150 pounds of nitrogen per acre. And this is very similar to most of our other long grains that we have out there. Switching gears to some of our plant population work. This is showing the DG263L seeding rate effects on plant population. On our x-axis we have our seeding rates ranging from 0 to 50 seeds per square foot, and the resulting plant populations at the 3-leaf stage of development on our y-axis. And here you can see about 72% of the seeds that we planted resulted in a surviving seedling to the 3-leaf stage of development. So what this tells us is we have pretty good seedling vigor with this particular variety, so there's not going to be any issues there. Looking at the plant population at the 3-leaf stage of development, here on our x-axis we have plants per square foot. On our y-axis we have our yield, and you can see that the optimum yield for this particular variety occurred somewhere between 13 and 16 plants per square foot. This puts us right in with our typical recommendation, which is generally between 10 to 15 plants per square foot to maximize our yield. So it tillers very well, this particular variety, and seems to follow our typical plant population spectrum. The official recommendation for this variety is going to be 15 to 20 seeds per square foot based on this particular research location, with a pounds per acre between 35 and 46 pounds of nitrogen per acre. This is not our official recommendation. This is just one location. We'll get to the official here in just a second. Here we see the same seeding rate trial, plant population trial on our clay soil at the St. Joseph location. This time you can see that we have a little bit lower seedling survival rate. About 64% of the seeds that we planted survived to the three-leaf, germinated and survived to the three-leaf stage of development. So we have a little bit lower vigor on this particular location, which we'd expect on a clay soil. And overall, when we combined all of our data, our recommendation for this particular variety is going to be 50 to 70 pounds per acre when we drill seed this variety. If you're going to water seed DGL 263L, we're going to recommend 70 to 90 pounds of seed per acre. Moving on to our next variety, I want to talk about some of our agronomic research. But I wanted to point out, if you remember from Dr. Levy's presentation and our survey that we did last year, CL153 made up 19.5% of the total rice acres in the state of Louisiana last year. Next year, in 2021, CL153 is only going to be available on a very limited basis. There will be some seed out there, but for the most part, we're not going to be able to get very much of that seed at all. So it'll probably drop down to 1% or less, and something's going to have to replace that particular clear-field long-grain variety. And the long-grain variety that's probably going to take up most of the CL153 acres is the CLL17. CLL17 is a variety that was developed by Dr. Adam Famoso here at the Rice Research Station. It has very good yield potential, very good disease resistance, and we'll talk about some of our nitrogen work here at the station and at some other locations as well with this particular variety. But overall, it's going to be a good variety for us, and here's what we saw with some of our research. Here's some of our nitrogen rate research at the Rice Research Station here in Crowley, on a Crowley silt loam soil. We did see some lodging here at this location at some of our very highest nitrogen rates. That didn't alarm us that much from this particular location. And here you can see again, as we increase our nitrogen rate, we increase our yield. Optimal nitrogen rate on the silt loam soil here at the station was found at 120 pounds of nitrogen per acre. When we looked at split rate nitrogen applications, it was at 150 pounds of N per acre. So this is what we saw at our the Rice Research Station locations. Now, we did see some lodging observed in other states, in Arkansas and Mississippi with their B/N trials, and this particular variety is going to be labeled or labeled moderately susceptible to lodging, and because of that potential for lodging out there, we're going to be very conservative with our nitrogen rate recommendations with this variety, and we're going to recommend that nitrogen be applied somewhere between the 90 and 130 pounds of nitrogen per acre, and not exceeding that 130 pounds of nitrogen per acre. Now, if you've ever grown CL151 in the past, it had a very similar nitrogen rate recommendation because it did tend to lodge as well. It was still a great variety, but it did have some lodging issues. So if you've ever managed CL151, you're going to want to manage CL117 in regards to nitrogen in the same way. Now, it might turn out that in the 2021 season that We really don't see any lodging with CLL17, and it may stand a little bit better than we think. And if that does occur and our research concurs with that, we'll be happy to increase the nitrogen rate. But until then, we're going to be conservative, and we're going to be between 90 and 130 pounds of nitrogen per acre. But as you can see, even with the lower nitrogen rates, we're still hitting some pretty good yields with this particular variety. So don't be scared to limit the nitrogen on this variety for that reason. Switching gears a little bit, I want to talk a little bit about furrow irrigated rice. As you know, furrow irrigated rice is really taking off in northeast Louisiana. A lot of our growers up there like it for many reasons, and a couple of the biggest reasons is they pull a lot less levees across the field, and so it's a lot less labor on their part and wear and tear on equipment growing rice in furrow irrigated manner. The other thing that they like a lot is they can prepare a field and make last minute decisions on whether I want to go with soybeans or rice or some other commodity based on commodity prices. And it's pretty easy to manage. But there are some pitfalls, and we'll talk about some of that. But just to give you an example how fast furrow irrigated rice has increased in Louisiana, you can see that in 2017 we had 2,500 acres furrow irrigated rice or row rice. 2018 that jumped up, it doubled to 5,000 acres. In 2019 it tripled to 15,000 acres. And then in 2020 we saw that furrow irrigated rice actually became an insurable practice, as well as alternate wetting and drying. And we saw over 30,000 acres of furrow irrigated rice in 2020 season. So I would expect that furrow irrigated rice, if we maintain high rice acres again, especially in northeast Louisiana, we'll probably see an increase in furrow irrigated rice. Now there are some issues with furrow irrigated rice that many of you are very familiar with. One is it makes weed control very difficult, or more difficult in furrow irrigated rice than our flooded rice. And to manage that, we're going to try to overlap our residual herbicides. Disease pressure, if you really don't want to try to grow a blast susceptible variety in furrow irrigated rice, because as you know, if you grow rice in aerobic conditions, you're setting yourself up for an increased disease pressure and blast. So if you were to combine a blast susceptible variety with a environment that is highly susceptible to blast, you could lead yourself into disaster. And we saw some of that last year when we had growers growing Jupiter or some of our medium grain varieties in furrow irrigated rice. Some of the things that we really don't know what is the best way to fertilize with nitrogen in furrow irrigated rice, because we are in an environment where we're wetting the soil and then we're going dry, we're wetting, we're drying, we're wetting and drying, especially on the top part of the paddy. It makes nitrogen cycle a little bit different as compared to if we were flooding that rice and stabilizing that nitrogen in the ammonium form. In furrow irrigated rice, we're actually going from the ammonium form to the nitrate form, and if we put water back on there and hold it, we can actually lose that nitrogen through denitrification. So we had the potential to lose a lot more nitrogen in furrow irrigated rice. With that in mind, we started a suite of furrow irrigated rice trials last year. In these trials, we looked at nitrogen rate. We also looked at nitrogen timing. Basically, if we were to spoon feed this nitrogen, what would be the best method of spoon feeding? We looked at different nitrogen sources. We included not just urea, but urea treated with a nitrification inhibitor, or urea treated with a urease inhibitor, or the combination of both of these. We also looked at the potential for ammonia volatilization with these nitrogen sources in furrow irrigated rice. And we replicated this not just here at the Rice Research Station in Crowley, but also at the Rice Research Station in St. Joseph on a clay soil. And graduate student Melanie Netterville is taking over for all of these furrow irrigated rice trials as part of her master's studies, and she's doing a great job, and we're going to show you some of the results from the first year of these trials. Here you can see this is going to be the Rice Research Station location on the Crowley loam soil, where we're looking at the optimum nitrogen rate. The variety that we used was CLXL 745, and what we did is we compared the single nitrogen application in a delayed flood system with a Faro irrigated rice system. So what you're seeing here in the blue bars represents our typical delayed flooded rice. The orange bars represent our Faro irrigated rice. The x-axis represents our nitrogen applied in a single application ranging from 0 to 210 pounds of nitrogen per acre, and our y-axis is yield. And here you can see that we had a much higher yield potential in our delayed flood rice, and most of that was due because we stabilized our nitrogen and we had better use of that nitrogen. If we were to compare optimum nitrogen rates, we would see that under this type of fertilization scenario, that 120 pounds of nitrogen would be optimum in our flooded rice for this variety, or this hybrid. And for furrow irrigated rice or row rice, it would be about 30 pounds of nitrogen higher, or about 150 pounds of nitrogen per acre, which is about about 75 pounds or more urea per acre. This next slide shows the effect of our different nitrogen application timings that we evaluated. This time we're looking at CL 153 in our furrow irrigated rice field, and this one is on a silt loam soil. On our x-axis you can see our different nitrogen rates in applications. The red bar here represents 0 nitrogen applied. The yellow bars represents a total nitrogen application of 120 pounds of nitrogen per acre. The blue bars represents a total nitrogen application of 165 pounds of nitrogen per acre. Here you can see we either applied that nitrogen in a single application, or we applied it in a two-way split application spaced 7 days apart, a two-way split application 14 days apart, and a three-way split application 7 days apart. And here you can see that if we were to apply 120 pounds of nitrogen per acre, that the two-way split spaced 14 days apart was statistically superior to the two-way split 7 days apart. And we also see a similar nitrogen response with a three-way split 7 days apart. If we were to look at the higher end rate of 165 pounds of nitrogen per acre, again we saw the same trends. The two-way split spaced 14 days apart was superior to the two-way split 7 days apart. And we also see that the three-way split 7 days apart was statistically similar to the two-way split 14 days apart. So this just tells us that if we're going to do a two-way split, probably a 14 days between applications is going to be more optimum, or we could go with that three-way split 7 days apart. Briefly, I want to talk about our general nitrogen fertilizer recommendations for drill-seeded delayed flood rice production. Here in the state of Louisiana, our nitrogen recommendations are really simple. We have 3 simple rules. The first rule is that we're only going to use ammonium or an ammonium-forming fertilizer like urea in rice production. And the reason of this is simple, is because ammonium nitrogen is going to remain stable under a flooded soil, while nitrate nitrogen will be unstable in a flooded anaerobic soil and will be lost very quickly through denitrification. So we want to avoid nitrate nitrogen fertilizers in rice production. We're going to apply 2 applications in rice production. Our first application, we're going to recommend that you apply that on a dry soil just before permanent flood establishment, when that rice is about 4 leaves to first tiller stage of development. And then we're going to want to flood that rice as soon as possible to incorporate that nitrogen into the soil, where it's going to go anaerobic and stay stable, where the rice can take that nitrogen up at its leisure. We're going to recommend about 2/3 of our nitrogen be applied at this time. with the remaining nitrogen being applied at mid-season, where we're going to apply the remaining 1/3 of that nitrogen need. Now, one thing that we know is if we leave our pre-flood nitrogen on the soil surface, exposed to the environment for longer than 3 days, we're going to begin to see a lot of that nitrogen being lost through ammonia volatilization. This is where that ammonium nitrogen is going to convert to ammonia, which is a gas, and simply float off the field. Research here at the Rice Research Station has shown that in a 10-day period of time, we can lose more than 30% of our nitrogen from ammonia volatilizations if it's left exposed to the environment. Also, we know that if we apply nitrogen on a wet or moist soil, it's also going to lose more nitrogen from ammonia volatilization in that wet environment. In these situations where it takes longer than 3 to 5 days to flood a field, we're going to recommend that you treat that urea with the urease inhibitor that contains the active ingredient NBPT. And there are a lot of different places where we can get NBPT, different brands, but if you'll check the label and make sure it has an adequate amount of NBPT, you should be good. So what is that going to do for us in general when it comes to yield or ammonia loss? And I just want to go very briefly over some historical research that we've done here at the station, just to show you how a urease inhibitor will stabilize the nitrogen and provide more nitrogen, which will in turn lead to more yield. So here we have the yield when we apply the same rate of urea fertilizer and leave it exposed on the soil surface 10 days prior to permanent flood establishment, 7 days prior to permanent flood establishment, 4 days, and 1 day before permanent flood establishment. And what you can see here is the longer that we leave it exposed on the soil surface, the more nitrogen that we're going to have lost, which is going to lead to more yield reduction. Here you can see just leaving it 1 day compared to 4 days prior to permanent flood establishment, we lost approximately 11% of that nitrogen, or 11% of that yield potential. So what happens when we take the same fields and we apply a urease inhibitor on that nitrogen and we leave it 1, 4, 7, or 10 days prior to permanent flood establishment? Well, this time we protected that nitrogen. Not only did we protect that nitrogen, but we protected our yield potential. That's why it's so important that if you're going to leave it exposed on the soil surface for more than 3 days, that we're going to recommend you apply a urease inhibitor on that urea. Or if you're applying that urea on a moist soil that's a little bit damp, you may also want to consider using a urease inhibitor. So just to reiterate, we only, in drill seeded delayed flood rice production, we only recommend the use of a urease inhibitors that contain either the active ingredient NBPT, NPPT, or duramide that have been tested in university research trials. And this is not a comprehensive list, but just make sure you read the label from whatever product you want to use and make sure that it has an adequate amount of NBPT, NPPT, or duramide if you're going to use that product. Now here in the state of Louisiana, we have a new company that's come in called Simplot. Now Simplot, like many of our large distributors, they have their own labeled products. Simplot has their Invictus line of products, and so what we did last year is we did a test where we evaluated some of the Invictus lines of urease inhibitors and nitrification inhibitors in rice production. And what we did is we looked at 4 different nitrogen sources in this trial. We looked at urea. We looked at their product called Volterra. Now Volterra has 20% DCD, which is dicyanamide, which is a nitrification inhibitor, and 20% NBPT in this product. And we applied it on urea at 4 quarts per ton. The next product that we looked at of theirs was Envale. Now, Envale is a urease inhibitor alone. It contains 26.7% NBPT, and it was applied on urea at 3 quarts per ton. The third product of theirs that we looked at is a product called Preserve N. Preserve N has a nitrification inhibitor only and some nitrogen as well, and it was applied on urea at 3 quarts per ton. And then we looked at the combination of the Preserve N with the nitrification inhibitor plus Envale with the urease inhibitor, pairing those two products up as well, and looking at how stable they were over a 10-day period of time and how that affected our yield potential. And here you can see that this nitrogen was applied 10 days prior to permanent flood establishment on a silt loam soil here at Crowley research location. We used a drill seed delayed flood rice production system, and here you can see that we definitely had a nitrogen response between no fertilizer and our urea. And then when we looked at our urea with the Valterra, you can see that we significantly increased our yields. Again, Valterra contains NBPT, our urease inhibitor, plus our nitrification inhibitor. When we looked at Envale, which is just the urease inhibitor with NBPT, you can see that we had a similar yield with the Valterra, which contains the additional nitrification inhibitor. And you see we really don't see an advantage of the Valterra over the Envale. When we look at DCD alone, with a little bit of liquid nitrogen, we see that the DCD alone does not stabilize our nitrogen from our urea when we leave it exposed on the soil surface, so it's not really giving us any benefit. But when we combined it with the NBPT from Envale, again we see that nitrogen is stabilized again from ammonia volatilization, and that our yield potential is similar. So basically what this is telling us is kind of what we've known all along, is that in our drill seed delayed flood rice production system, where we're going to flood that rice after our nitrogen application to stabilize that nitrogen in the ammonium form, we don't need a nitrification inhibitor. We only need the urease inhibitor, and that's going to give us our benefit. However, if we were in a row rice situation, that would be different because now we're going from an aerobic to an anaerobic and back to an aerobic form. And in a row rice situation or furrow irrigated rice, a nitrification inhibitor like a DCD product may give us some advantage there, where it's not going to give us an advantage in our flooded rice. So with that, I'm going to shore up my time today. Feel welcome to call me at any time. I may no longer be the rice extension specialist, but I'll be welcome to answer any agronomic or fertility calls that you may have. That's my contact information on the screen. Again, you can follow us on Twitter at Louisiana_rice. You can also get the field notes. Dr. Levy will be taking that over this year. And we'll also keep up with our group text message list. And if you'd like to get on that list, just get a hold of Dr. Levy or myself, and we'll make sure that we'll get you on that. Without further ado, thank you for joining us today, and we'll talk to you again next time.